We were looking at applications around the manufacturing floor, and we were looking for repetitive operations in production. What we wanted to do is try and get ways of overcoming those, so we see this as an ideal opportunity for a collaborative robot in the blasting area. The blasting process was highly manual, leading to a lot of repetitive strain issues.
Anybody who's involved in the masking process here at Stryker, it's the mundane, day-to-day thing that you have to do with the blasting. I think it's the real bane of their lives inside here when you're here for 12 hours on any given day or night.
Stryker came to us with a requirement for a collaborative robot, and that we looked at a sandblasting process which we felt was a very suitable job for us to do, the first one to start with Stryker. So we utilised the UR10 Universal Robot, and we came up with a collaborative blast cell which is in production currently. The Universal Robot was a perfect match for the requirement in that it worked outside the cage and it took up minimal space.
The system itself is very user-friendly. It was very easy to learn. I've never had a background in robotics before, but this robot that's after coming in is after 1 hour you know how to program it. It's as easy as picking up something like an iPad and playing with it, and you can move it around and move it into position and set it up the way you want it. It's simple.
Show that. Position number 3, and this is drop off.
A lot of the times you would get 12 parts in each batch. For argument's sake, if we had 11 parts, you place your 11 parts on the carrier and you have a stem, which we call a stop stem, that the robot can pick up that the diameter of the ball in the top of the stem is slightly bigger, and it'll know that that's the end of the batch.
Collaborative blasting robot is a fantastic application. It's taken a very manual process to a much more user-friendly operation step, reducing human errors and making first-time quality parts.
Additional safety features mean that if an operator enters the shared area while the robot is there, the robot will stop. It is a simple push-button step to restart the process.
Human error is a fact of life. You know, if you were to miss a part when you're putting it in the carrier, automatically when the robot can pick up that part is missing, like, straight away it'll shut it down, and the robot arm will actually point to the sign that we have, like with the out of media, part missing, check media. So at any given stage, like, it makes it so simple. It'll prompt you every time.
So in terms of validation, the complexity of it wasn't that great. It followed the standard equipment installation, and the process itself is 100% verified, so there wasn't really any need to do any PQ, but a business decision was made to just, I suppose, correlate the results from previous processes. And I'd say going forward, to be, I suppose, pragmatic and take a lean-based approach, that I'd say for future universal robots doing a similar process, I would advise doing equipment qualification and defaulting to the 100% inspection.
It's been a fantastic success for us in the business unit. It's a very positive step from a technology perspective, from an engagement perspective, and we see huge opportunities for it across a range of applications specific to the coatings business unit, but on a wider scale there are massive opportunities here to be harvested.
So this was a pilot study that we did inside in the blasting area. We have a lot of learnings from it. So if we go and roll this out into other applications, we're going to see the cost reduced down to approximately 100k per application that we do, depending on the complexity of it.